Welcome to my YouTube channel, A Binary of Civil. In this session, I would like to discuss about the second assignment of Geotechnical Engineering-II. First question. The shear strength of a material is its response to compression. So that is the meaning of the statement is whenever we get compressed the soil by using road rollers, its shear strength will develop. Is it correct or wrong? We have an equation, shear strength tau F is equal to C plus sigma bar tan pi. So in this, C is cohesion, sigma bar is equal to effective stress. So that is effective stress means it was the stress carried by the solid particles when they will be made as touch together. By using compression, all these particles will come closer. Okay, one particle will lay over other. Okay, so the effective stress increases. When effective stress increases, shear strength increases. This is a correct statement. It is applicable for both cohesive and cohesionless soils. Okay. Next question. The drained shear test allows. Drained means drainage will be allowed. When drainage will be allowed, obviously the water which is inside the sample will move out. That is, there is no development of pore water pressure. Okay, pore water pressure will dissipate. Okay, so the answer is C for question number 2. Now, question number 3, clay seam sandwiched between two sand layers. For example, in first case he explained it is clay and there are sand particles above and below. So obviously it is a form of double drainage. He asked us to get incorrect statements. In the second, so first statement is correct. In the second statement, clay seam with sand layer on top. So that is only sand is on top and bottom is rock. So it is one-way drainage or single drainage. Okay, but he mentioned that it represents undrained condition. Obviously, this is wrong statement. So for question number 3, B is the answer. Remaining statements, shear strength parameters are useful for analysis of foundation. During foundation, shear strength parameters here are C and pi, that is cohesion and angle of internal friction, and bracings and struts and slope stability. And coming to final, undrained condition in triaxial test can be achieved by fast shearing. This is the most important. So we will conduct the triaxial test in undrainage. So that is the drainage will not be allowed. When there is no allowance of drainage, so there is a chance of getting pore water pressure. So to develop this undrained condition, the shearing should be very fast. Okay, so question options 3 and 4 are correct. So second option is wrong. Next, the plane between two halves of the sample in direct shear. For example, this is a direct shear box you will have. So this is a sample. And this plane we call it is, this is actually a failure plane. This failure plane is called shear plane. And over this there is a dial gauge. This dial gauge records vertical deformation. And here on the surrounding you will have a proving ring. Very important. Proving ring will record shear deformation. So 3 points here. The failure plane is a shear plane and this vertical deformation will be measured with dial gauge and horizontal deformation will be measured with proving ring. So for question number 4, B is the answer. And which points in the figure corresponding to peak and residual? Obviously this is the topmost point and this is a Stress increased and decreased again, came to certain constant value. This is residual shear strength. Here it is a peak value. So points 2 and 4 will indicate peak shear strength and residual shear strength. So question number 5, option C is the answer. At point 4, what would be remains constant? So that is here, whenever there is a shear stress and axial strain increases, whenever the axial strain increases. So at finally point 4, volume of the sample will become constant. Okay. So for question number 6, answer is A. Yeah, just discussed vertical deformation. So vertical deformation can be measured in direct shear test with proving dial gauge, and shear deformation proving ring. So you need to remember this. He has given both the options, no? So to measure this vertical deformation, dial gauge, shear deformation, proving ring. In the last diagram I explained. And cohesion in sand is possible due to following. Obviously, during, especially in dry sands or in cohesionless soil, cohesionless soils or dry sands, because of interlocking, cohesion will be developed. So question number 8, it is A is the answer. Next question. During direct shear test on dry dense sands means cohesion is 0 and shearing stress is tau is equal to 6 kilonewton per meter square, was recorded at failure. Shear stress at failure is nothing but it is a shear strength. So I write it is tau F is the shear strength. And angle of internal friction phi is equal to 38 degrees. What was the normal stress? So we have an equation, shear strength tau F is equal to C plus sigma tan phi. Here normal for dry sands C is 0. We want normal stress. That will become tau F divided by tan phi. Tau F is equal to 6. Tan phi will become tan 38. So you will get answer 7.68 kilonewton per meter square. You just enter. It is something like it is, they haven't given any options. They asked you to fill the answer. Okay. So GATE exam, most of the questions are of this type. And question number 10 and 11 are interlinked. So this is solution for question number 10. It is for 11. Coming to question number 10. A triaxial test on an identical sample of this sand. Sand is C is equal to 0. Conducted on a cell pressure sigma C is equal to 8 kilonewton per meter square. Calculate major principal stress at failure. And he has given already phi is equal to 38 degrees in the earlier problem. Of this sand means earlier problem sand. So now major principal stress sigma 1 is equal to sigma 3 tan square alpha plus 2c tan alpha. As C is 0, this term will get 0. Sigma 3 is nothing but it is confined pressure. So confined pressure sigma 3 is equal to 8. Tan square alpha is equal to 45 plus pi by 2. Pi is 38. So you will get sigma 1 is equal to 33.63 kilonewton per meter square. Okay. So 33.63 is the answer for this. And in the 11th question, at what additional deviator stress? Obviously, sigma 1 is equal to sigma C plus sigma T. Sigma C is 8 he has given. Sigma T is a deviator stress we required to make the sample fail. So sigma 1 we calculated 33.63. From this equation, sigma D we will get it is 25.63 kilonewton per meter square. Okay, so this is also fill in the blank. So you need to enter answer very properly. If you enter like 24, 23, so it will go wrong. Okay, and one more thing you need to remember is for fill in the blank questions, there is no negative mark. Okay, so you can enter whatever the value that you get, but be careful. And obviously, what is the type of testing, whether it is related to field test or laboratory test. So very clear that Vane shear test is field test. Clear, that is 1, 2, 3, 4. 3 is 1. Vane shear test, something like there are two diametrical plates and there is a shaft. We rotate like this in the field. So it is applicable only for soft clays. And direct shear test is completely disturbed sample we will get, something like it is in the sand. So for question number 1, it is a lab test. So that is 1, it is 2. Okay, so 1 it is 2 and 3 it is 1. And triaxial test we can conduct either in the field or in the laboratory. That is an instrument which requires completely undisturbed sample. That is triaxial test is both 2 it is 3. Clear? And so the remaining 4 is again flat jacks we can provide it in the field as well as in the laboratory. So it is 3. So the question for question number 12, the answer is A. And for the last question for this assignment, the over consolidation ratio of the soil would depend upon. Obviously, previously, let us take in an area there is a temple. Now the temple has been removed. That is, the soil present below the temple will be consolidated already. Present it is not there. So that is depositional history. That is, in the history, is there any structures like that? So it will depend upon depositional history. And rate of shearing. Rate of shearing means, for example, there is a lot of ice. You can see here in this ground, there is a lot of ice here. Okay, this is ice block. So this ice block completely sheared and melted. That is, the load over this soil gets reduced. The soil which is below has already consolidated. It became over consolidated. So that is, over consolidation ratio of the soil depends upon the past history and at which of the rates. That is, rate at which it is getting sheared. Okay, on these two factors, the over consolidation ratio depends. So for question number 13, C is the answer. Okay. I hope you liked the way I have explained. Thank you.